Have you ever wondered how we came to dominate every inch of the planet? And what makes us unique as a species? In the vast animal kingdom, many creatures have perfected incredible abilities. Birds migrate thousands of miles without maps, beavers build complex dams, and ants organize astonishingly efficient societies. But we, humans, stand out for something entirely different. Our ability to learn, adapt, and create technology at a pace that, in evolutionary terms, is almost instantaneous. While other species may take millennia to develop new strategies or skills, we have gone from chipping stones to exploring other planets in the blink of an eye. In just a few centuries, we have transformed the world and our own lives in ways that no other species could have imagined. This talent for innovation and reinventing our reality not only sets us apart, but also raises fascinating questions about who we are and where we are headed. How did we achieve this evolutionary leap? Today, we're going to travel 100,000 years back in time to understand it better. Our ancestors lived in a completely different world, facing nature with rudimentary tools and limited knowledge. What were we doing back then? And how did those early innovations lead us to where we are today? Come with me as we explore that fascinating chapter of our history. We must not forget that our species, Homo sapiens, emerged from a brutal world full of challenges and dangers. The human intellect, as we know it today, is the result of thousands of years of astonishing ideas and cultural advancements. Seemingly simple tools like needles for sewing or fishing hooks once required a genius comparable to that of an Einstein of their time to be conceived. Beyond practical tools, symbolic creations such as carvings or drawings represented a level of cognitive innovation that marked a turning point in our history. Although today we consider ourselves extremely intelligent, we owe this perception to the advanced global culture we live in. If modern humans' descendants were thrown into a Stone Age world and managed to survive, many of the ideas we take for granted would likely take thousands of years to emerge again. This underscores a crucial fact. Every culture on Earth is both a product of millions of years of evolution, just like our bodies. 100,000 years ago, our cultures and skills already showed an impressive degree of sophistication compared to earlier stages. By then, our species, anatomically speaking, had already existed for about 200,000 years. However, it's important to distinguish between anatomical modernity and behavioral modernity. The Homo sapiens of 300,000 years ago looked physically like us, but their behavior and material culture were much less complex. As the Middle Paleolithic progressed, we began to see more modern behavior. Around 100,000 years ago, the first signs of this transformation included the use of more sophisticated tools, the creation of personal ornaments, and evidence of more complex social relationships. These changes marked the beginning of a cultural revolution that laid the foundations for the advanced societies we know today. However, many paleoanthropologists believe that Homo sapiens did not fully achieve behavioral modernity until around 50,000 years ago. This shift is not only supported by material findings, but also by a series of key genetic mutations that began to spread among the populations of the time, possibly influencing cognitive abilities like creativity, long-term planning, and complex communication. On a remote coast of South Africa, about 100,000 years ago, a group of humans worked in a natural shelter known today as Blombos Cave. There, surrounded by the vastness of the ocean, these early artisans created tools and art that reflected a complexity and foresight far ahead of their time. Imagine one of them holding a rough stone, first striking it with a stone hammer to shape it. Then, using softer tools made from bone or antler, they refined the edges with precision. Finally, applying a technique known as pressure flaking, they detached small flakes to perfect the tip. This technique, involving controlled pressure with fine tools, wouldn't become common until tens of thousands of years later. But their innovation didn't stop there. They discovered that by carefully heating the stone in fire, it became more fragile and easier to work with. This combination of techniques displayed a profound knowledge and an experimental capacity that hinted at advanced technological mastery. However, not everything was practical. Some tools seem to have been rejected for not reaching a certain aesthetic perfection, while others, carefully crafted and polished, seem to serve a more symbolic or ritualistic purpose. Some intact pieces were even found abandoned in the cave, as though they had been offered or reserved for something more meaningful than daily use. This level of aesthetic detail wouldn't be observed again until thousands of years later in cultures like the Solutrean in Europe. But Blombos was not just a tool workshop. In its depths, pieces of ochre with geometric patterns etched on them were found, crossed lines that might be the first forms of abstract art in human history. These engravings speak to a mind capable of symbolism and abstraction, a deeply human trait. And near these carvings, small perforated shell beads provide another clue to their complexity. These primitive jewels, likely used as adornments, were not just aesthetic, they reflected identity and belonging, an early form of personal expression. Blombos shows us that 100,000 years ago, our ancestors were not just crafting tools for survival, they were experimenting, innovating, and beginning to shape ideas that connected them with each other and with their world. There, in that corner of the planet, symbolic thinking and art came together for the first time, laying the foundations of what makes us human. The emergence of modern behaviors also coincides with the spread of certain genes related to brain development. Among these, mutations in genes like FOP2 associated with language are believed to have played a key role in communication and knowledge transmission. These cultural innovations were not limited to technology or art. For example, the existence of trade networks, evidenced by non-local materials, suggests that early humans already maintained long-distance trade and collaboration systems. One of the most ancient and fascinating finds at Blombos is a fragment of rock with 9 red lines drawn about 73,000 years ago. These lines, made with red ochre, represent the oldest known drawing to date and offer a direct window into the creative thinking of the cave's inhabitants. This iron-rich material wasn't only used for drawing, but also for other symbolic purposes. Over 8,000 pieces of ochre have been recovered, many of which were etched or scraped to produce powder. This powder, mixed with charcoal and animal bones, was stored in abalone shells, serving as portable pigment kits. The inhabitants of Blombos seem to master the technique of preparing these pigments, producing a viscous paste that may have been used to paint their bodies, tools, or even for ritual ceremonies. The diet of the Blombos inhabitants reveals a complex strategy for resource utilization. They consumed both marine and terrestrial animals. Among the remains found, there are fish, shellfish, seals, and dolphins, suggesting that the latter were collected after strandings. They also hunted large mammals, small animals, and turtles, using specialized techniques that allowed them to exploit a wide variety of prey. The diversity of their diet reflects not only adaptation, but also planning and collaboration within their groups. Meanwhile, in other parts of Africa, innovations were also emerging that complement what we know about Blombos. For example, in the Symbolic River Basin in present-day Democratic Republic of Congo, bone harpoons dated to 90,000 years ago have been discovered. These tools, designed to capture large fish, not only stand out for their functionality, but also for their intricate decoration, suggesting a symbolic or even ceremonial significance. Similar findings at places like Sibudu Cave, where traces of composite adhesives and perforated needles have been found, strengthen the idea that these human cultures were not just skilled survivors, but also innovators and creative thinkers. These technologies and cultural practices demonstrate a level of sophistication that transformed early humans' relationship with their environment and each other. The harpoon tips found in the Semliki River Basin in present-day Democratic Republic of Congo are remarkable for their size and design. These tools were large and robust, with multiple prongs and grooves designed to trap large fish once speared. It is believed that these weapons were used to capture huge fish, such as the giant catfish, an abundant prey in the region. The evidence is overwhelming. The remains of thousands of giant catfish bones found at the site suggest that this culture heavily relied on aquatic resources. During this period, the conditions in eastern and northern Africa were significantly wetter, creating an ideal environment for the rise of fishing cultures. Further east, in Kenya, one of the earliest examples of intentional burial in our species has been discovered. A child around 3 years old was buried in a small pit, representing a significant moment in the history of human symbolic behavior. Chemical analysis and the arrangement of the remains indicate that the burial was deliberate. Additionally, crushed snail shells were found beneath the body, which could be evidence of symbolic rituals related to death. While Neanderthals had shown signs of funerary practices, this find is the oldest attributed to Homo sapiens, marking an advance in the social and cultural complexity of our species. In North Africa, the Aterian culture, which flourished between 145,000 and 20,000 years ago, left an impressive legacy of technological innovation. It is known for its distinctive flat-based points, called tanged points, which allowed for more efficient attachment to shafts or spears. This design not only provided greater stability to the projectiles, but also improved their penetrating power. Some of these points, due to their size and shape, suggest they may have been used as light dart tips thrown with an atlatl, a propellant that increased the speed and range of the weapon. Although direct evidence of the atlatl dates back to about 20,000 years ago in Western Europe, the possibility that this technology existed in Africa more than 100,000 years ago is intriguing. In addition to their tools, the Aterian culture produced specialized bone artifacts, bifacial knives, and symbolic ornaments such as shell beads. These beads, found even hundreds of kilometers from the coast, are evidence of extensive trade networks that span the continent. Meanwhile, outside Africa, the first members of our species began to expand into the Middle East. The oldest fossil identified as Homo sapiens outside of Africa is a jawbone found in Israel, dating back about 190,000 years. For tens of thousands of years, our species settled in this region, where they likely encountered other human species, such as Neanderthals and Denisovans, marking the first episodes of interaction and possibly hybridization between different branches of the human lineage. These encounters in the Middle East represent the beginning of a global expansion that would forever change the history of our planet. It has long been known that Neanderthal populations extensively occupied the Middle East, but recent discoveries at sites such as Nesher Ramla in Israel have revealed the existence of a distinct human population. The remains found, including a skull and jaw, date from between 140,000 and 120,000 years ago, and display unique features that distinguish them from both Neanderthals and Homo sapiens. Their robust jaw resembles that of early Neanderthals, or even older species like Homo heidelbergensis, suggesting that this group could represent an intermediate link in human evolution in the region. These discoveries reinforce the idea that the Middle East, located between Africa, Europe, and Asia, was an important crossroads for human diversity around 100,000 years ago. During this period, Neanderthals appear to have been the predominant inhabitants of the region. Evidence from several archaeological sites, such as the Kabara and Amud caves, shows that they practiced complex behaviors, including ritual burials and the use of pigments like red ochre, a symbolic material used by them and other human species. Neanderthals were not only hunters of large game such as mammoths and woolly rhinoceroses, but also versatile foragers. Their diet included seafood, fungi, and even plants, demonstrating an ability to adapt to a wide range of environments. Beyond their sustenance, Neanderthals also developed symbolic and artistic skills. In the Bruniquel cave in France, a structure made up of hundreds of stalagmites arranged in a circular pattern dating back more than 176,000 years was discovered. This finding suggests a level of abstract thinking much greater than initially attributed to them. Another fascinating example comes from Krapina, Croatia, where perforated eagle talons were found, likely used as ornaments. This type of rudimentary jewelry supports the idea that Neanderthals valued symbolic objects. Bone fragments with markings, potentially related to mortuary rituals or complex cultural practices, were also discovered. While the Neanderthals developed these capabilities, our species mostly remained confined to Africa and parts of the Middle East. Early migrations of Homo sapiens may have reached the Indian subcontinent, but evidence in these regions remains limited. At the same time, East Asia, with its diverse landscapes ranging from high mountains to tropical islands, was home to other human species. In Siberia, the Denisova cave revealed a hominid population known as the Denisovans. Although the cultural materials from the cave are only about 50,000 years old, genetic remains show that Denisovans lived there at least 100,000 years ago. One of the most surprising findings is Denny, a hybrid teenager with a Neanderthal mother and a Denisovan father. This not only demonstrates the coexistence of these species, but also their direct interaction, including reproduction. Denisovans, whose genes persist in modern populations in Oceania and Southeast Asia, also inhabited mountainous terrain such as the Himalayas, where their genetic adaptation allowed them to thrive at extreme altitudes. This level of adaptation reflects a unique evolutionary development that sets them apart from other human species. The discovery of Neanderthals in Siberia and Denisovans in northwest China represents the known geographical limits of these two human species. The Denisova cave in Siberia and a site in the Qinghai province of China are the only places where Denisovan DNA has been identified so far. However, the lack of genetic evidence at other sites does not mean these species did not inhabit broader areas. The technology and remains found suggest a complex and still incomplete history. The material remains associated with the Denisovans include typical Middle Paleolithic tools, such as large hand axes and wooden spears. However, a finding in China stands out due to its sophistication: a rib from a large mammal engraved with crossed lines and covered in red ochre pigment. While this may seem like a simple object, its age of over 100,000 years makes it an important indicator of the symbolic and cultural capacity of these populations. Despite this, it cannot be ruled out that this object may have been created by another human species from the region, such as Homo longi, known from a nearly complete skull discovered in northeastern China. The Homo longi skull, nicknamed the Dragon Man, shows similarities to other remains from the region, such as the Harbin jawbone. Some researchers suggest it could represent a Denisovan, though without genetic evidence, this claim remains speculative. The same holds true in Southeast Asia, where modern human populations have a higher proportion of Denisovan DNA compared to other regions of Asia. This could indicate that Denisovans were present and even common in Southeast Asia before the arrival of Homo sapiens. In this region, fossil remains include some classified as Homo erectus, such as Java man or Solo man. However, certain researchers argue that some of these may be Denisovans, a hypothesis that would require genetic testing to confirm. Regardless of their classification, the materials found at these sites reflect remarkable technological sophistication. At the Solo Man site, bone and stone tools have been discovered, including points possibly used to hunt stingrays, harpoons, and stone balls that could have served as hammers or even bolas to capture animals. 100,000 years ago, the world was not only inhabited by a great diversity of human species, but it was also an evolutionary laboratory where geographical and ecological conditions shaped living beings in surprising ways. A fascinating example of this is the phenomenon of insular dwarfism and gigantism, evolutionary processes that transform species in response to the unique conditions of islands. In the same insular region of Southeast Asia, we find another fascinating human species, Homo floresiensis, also known as the Hobbit. These hominids inhabited the island of Flores and were notably small, with adults measuring only 1.06 meters and weighing around 35 kilograms. Their small size is a classic example of insular dwarfism, an evolutionary phenomenon where species isolated on islands tend to reduce their body size over time. Despite their size, these hominids were capable of making advanced stone tools, suggesting that they possessed intelligence comparable to other species of the genus Homo. Insular dwarfism is not limited to humans. On Flores, dwarf elephants such as Stegodon coexisted, weighing only a fraction of what their mainland relatives would have. This phenomenon occurs when large species, isolated on islands with limited resources and few predators, evolve to reduce their size and needs. On the other hand, for predators like Komodo dragons, insular gigantism can occur. Being at the top of the food chain on islands with little competition, these reptiles could grow to become the giant predators we know today. Insular gigantism and dwarfism are two sides of the same evolutionary coin. They depend on factors such as resource availability, the presence or absence of predators, and the dynamics of competition. For example, on small islands with closed ecosystems, large animals tend to shrink, while on larger isolated islands with more expansive ecosystems, small animals can grow without limits due to the lack of natural predators. On the nearby island of Luzon in the Philippines, we find another intriguing example of insular dwarfism with Homo luzonensis, a hominid species that, although we cannot yet estimate its size precisely due to limited remains, shows primitive characteristics similar to those of Homo floresiensis. This species would have had to cross Huxley's line, a biogeographic boundary marked by deep marine channels, suggesting that they possessed some form of rudimentary maritime technology. The ability to navigate, even if limited, adds another layer of complexity to these island populations. But the islands of Southeast Asia were not only a stage for dwarfism. In other parts of the world, such as Madagascar, we find examples of insular gigantism in species like the elephant bird, Aepyornis, which grew to over 3 meters in height, and giant lemurs, which far exceeded the size of their modern relatives. These species evolved in the absence of significant predators, allowing them to grow without restrictions. Thus, we conclude this journey to the past, a fascinating glimpse into a key moment in human history. This period not only shows us the diversity of our roots, but also the shared ingenuity of all these species. It serves as a reminder that although we are the only ones left, we are the result of a rich and complex web of evolutionary experimentation.